Hello everyone! In this video, we're gonna solve another normal stress problem, but this one will involve the analysis of a truss. So here, we have a truss which is loaded at point C, E, and G, and it has a pin support at point A and a roller support at point H. Knowing that the cross-sectional area of the member is 5.87 square inches, we need to determine the average normal stress in the member BE. So let's get started. The first thing we would do is to draw a free body diagram of the structure. This is with the purpose of finding the reaction forces. In this case, we have the reaction forces at point A and the reaction forces at H. Once we have the free body diagram, we can take the moment about point A so that we are able to find the reaction force at H. If we sum all the moments about point A and make them equal to 0, we will be able to find the reaction force at H. In this step, we found that the reaction is 120 kips. Now, if we apply the other two equilibrium equations, we are able to find the reaction forces at point A. From the equilibrium equations, we found that the reaction force going along the y direction at point A is 120 kips, while the reaction at point A along the x direction is 0. Once we have the reaction forces of the truss, we are ready to move on to the next step. This step is to make a cut from member BE all the way to member CE to determine the forces of the member. In this case, we're interested in finding the axial load along member BE. When we make the cut and take section AA, we can see the internal forces of member BD, member BE, and member CE. From the free body diagram of section AA, we can see that force BD and force CE go along the x direction. However, force BE has two components, the vertical and the horizontal component. Therefore, that will need a little bit of trick and geometry to find the angle, to find the components of force BE. By looking at the truss, we can see that joint B, joint C, and joint E make a right triangle, which is drawn on the right. This triangle has a height of 16 and a base of 12. If we take the inverse of tangent of the base divided by the height, we can get theta. Theta is 36.87 degrees. From here, we can break force BE into components. When we have the components of force BE, we are ready to apply the equilibrium equations. This is with the purpose of finding the magnitude of the axial force of member BE. So here we have three different options. We either take the sum of all the forces along the y direction, the sum of all the forces along the x direction, or the sum of all the moments about a single point and make them all equal to 0. When we're trying to solve for an unknown, we have to make sure that you start applying the equilibrium equations using the equation that will involve the less unknowns. In this case, it would be the sum of all the forces along the y. Since the only forces acting along the y direction are a sub y, which is already known, the external load applied at C, which is 80 kips. In this case, the only unknown will be the axial force of member BE. Once we sum all the forces acting along the y direction, we obtain that the force along BE is equal to 50 kips. And from here, we don't have to find the forces along member BD or member CE because they are not required. The only force we need to solve this problem is force BE. Now we're ready to take the last step, which is to find the normal stress in member BE. If we recall from the introduction to normal stress video, we know that the normal stress is equal to the normal force acting on a member divided by its cross-sectional area. In this case, the normal force along member BE is equal to the axial force F of BE. If we divide 50 kips by 5.87 square inches, which is the cross-sectional area of the member, we obtain that the normal stress along member BE is 8.52 kSI, and that will be our final answer. I hope this video has helped you understand a little bit more the concept of normal stress, and also to analyze the normal stress along the members of a truss. Thank you for watching.